In this video, we will solve a problem that includes heparin with a protocol. If you do not understand the process of infusing heparin with a protocol, please click on the word protocol to go to a video that explains what's happening in the body when heparin is infused. We will be using this protocol to solve the problem. First off, notice in the upper left information on the initial bolus and the initial infusion. We'll definitely be using that. In the chart itself is information from when we get our APTT result. We'll use the chart after we have our first blood test. At the bottom of the protocol are the maximum amounts. Make sure that you're never administering more than the maximum amount for the bolus, the infusion, or for a repeated bolus amount. Let's take a look at the actual problem. Heparin protocol problems can feel overwhelming because there are so many steps. However, each step is very straightforward and not a lot of calculation. When we read this problem, it says based on the above nomogram, which is another word for protocol, calculate the following for a patient weighing 73.4 kilograms. Part A, we're to calculate the initial bolus in units. Looking back at our protocol, we see that the initial bolus is to be 70 units per kilogram and not to exceed 10,000 units. So we're ready to do our calculations. From the protocol, we're to give the patient 70 units per kilogram. We'll need to multiply that by the patient's weight of 73.4 kilograms to get a label of units. I put this over 1 as a placeholder. I see that the kilograms cancel and the remaining label will be the label of units which the problem asks for. So grabbing my calculator, I take 70 times 73.4 and get my answer of 5,138. The label on this, as we talked about before, is units, and we mentally double check. This is not above 10,000, which was the maximum, so we will administer the calculated dose. Part B. The initial bolus in milliliters if heparin for injection is available at 10,000 units per milliliter. We're going to take our answer from Part A, and that is the desired amount. Some of you prefer to do the nursing formula or to do a proportion. I'm going to set this up using dimensional analysis, although any of the methods would work. So we want to give our patient 5,000 units as a one-time dose because a bolus is given as an injection. Available to us are 10,000 units in 1 milliliter. Again, our units will cancel so that we have an answer in milliliters, which is what we were asked to calculate the bolus in milliliters. Once again, I turn to my calculator. I already have the 5,000 number on my calculator. All I need to do is divide it by 10,000. And I get my answer. When I look at my answer, I need to know how to round. Since this is milliliters less than 1, it would be given with the 1 milliliter syringe, which is calibrated to the hundredths position. Therefore, I will round to the hundredths location and administer 0.51 milliliters. Now I'm ready to move to Part C. Part C asks me about the initial infusion, and I'm to find a label of units per hour. I return to the protocol. The initial infusion is to be 15 units per kilogram per hour. That's going to be my starting piece of information. So I start with 15 units per kilogram per hour. The hour I want to keep because that's part of my answer, but I don't want to have a kilogram in my answer because the answer label is to be units per hour. So I will multiply by the patient's weight, which is given as 73.4 kilograms. This will allow me to cancel the label of kilograms and to have the answer in the label requested. I'll multiply using my calculator. So let me clear. I'll take 15 times 73.4 and calculate 1,101 units per hour. Next question asks me for the initial infusion rate. That's the same thing I was working with in Part C, but now I'm to give a label of milliliters per hour. The question also tells me what's available in the IV bag. For this problem, I'm going to start with my answer from Part C. So I have 1,101 units per hour. I want the units to cancel, so I'll use the IV bag that has 25,000 units in the denominator, and that amount is in 250 milliliters, so that will go in the top of my fraction. And again, you could set this up using a proportion or using the nursing formula. Any of those would work. So units cancels. My remaining label will be milliliters per hour. So I go to my calculator. I already have the 1,101. So I will multiply that by 250 and divide that by 25,000. This is a milliliter per hour rate, and since it is a milliliter per hour rate, I need to round it to the nearest tenth. When I look at the tenth, it is a 0. With the metric system in the medical profession, we never leave a trailing 0. So my final answer is going to be 11 milliliters per hour, even though technically it would have been 11.0. But I don't want to have that trailing 0 in case the decimal would be missed. It would be a huge error. I've already completed 4 parts of the problem. Each of them was only one step. So the overwhelming part is how many parts there are, but the math is very straightforward. And now, Part E. You receive an APPT result of 45. This means I need to go back to the protocol and see what to do based on this clotting time for my patient. So I'm going to look in the protocol. 45 would be between 35 and 50. In the protocol, I need to repeat the bolus at 35 units per kilogram, and I need to increase the rate by 3 units per kilogram per hour. So I'm going to go back and look what the question asked me to calculate with these numbers in mind. First is the new bolus. We read that the new bolus should be 35 units per kilogram. The answer here is to be with the label of units, so I'll need to multiply by the patient's weight of 73.4 kilograms, and that will cancel my label of kilograms. So go to my calculator. 35 times 73.4, and I get an answer of 2,569, and the label on that is units. Now, just like the initial bolus, I cannot go over the maximum. When I go back and double check, this double asterisk, the maximum for that bolus was 5,000 units. At 2,000 some units, I am below the maximum, so I will give the calculated dose. The next part asks me to find the new bolus in milliliters. So I'm going to take my answer from the previous part and convert it over to milliliters. I can use dimensional analysis to do this. I can use the nursing formula. I can use a proportion, whichever method is most comfortable for me. I'm going to set it up as dimensional analysis, but you can use any of the methods. Again, I'm going to go to my calculator to do the math. The label of units cancels to give me a label of milliliters. I already have the 2,569 on my calculator, so I just divide by 10,000. Because this is going to be given with the 1 milliliter syringe, I need to round it to the hundredths place, so I'm going to give an answer of 0.26 because the 5 rounds up, and that is in milliliters. Next, it asks me about the new infusion rate in units per hour. When I look back at my protocol, the new infusion rate is to be increased by 3 units per kilogram per hour. The label on that increase was units per kilogram per hour. So I need to find where I had units per kilogram per hour, and I had that in part C. I was at 15, so 15 plus 3 gives me 18 units per kilogram per hour. I can only add when I have matching labels, so that's why I had to find in my work the matching label. The answer here is to be given in units per hour, so I need to convert this by multiplying by kilograms to cancel that label. And I'll go to my calculator to do the math. So 18 times the weight of 73.4. And I do not round at this step because this is not a final answer. So I have here 1,321.2, and the label on that is units per hour. Last part of the problem is to find the new infusion rate in milliliters per hour. So I'm going to take my answer from the previous part and convert it over to milliliters using what is available in my IV bag. When I set this up with dimensional analysis, I want my labels to cancel. But here again, you could set this up using any of the methods. So you could use the nursing formula, or you can use the proportion, and both of those will give you the exact same answer. Units will cancel, and I'll have my answer in milliliters per hour. So I already have this number on my calculator. I multiply that by 250, and then divide that by 25,000. Here I do need to round my answer because I need to type this into my infusion pump, and the infusion pumps will take values to the tenths, so this would be 13.2 milliliters per hour. At this point, we have completed a problem with a heparin protocol. You'll notice that there were a lot of steps, but each step had only one calculation to do. And so even though the problem can feel overwhelming, the math that you need to do is not overwhelming. It's just one conversion, one multiplication per part.